Hey, hi everyone. Welcome back to CodeTav Management. So for the Spring Boot JPA related, that is the third video. So in part one and part two, I have discussed the basic understanding of the Spring Boot JPA and then the architecture of the Spring Boot JPA. So now we will mostly deep dive into the first level cache, which is the persistence context. So, I think, have you ever looked at your Spring Boot console and wondered why is Hibernate executing a database query here, but not over there? So or maybe you thought my Hibernate cache is broken. So if you think that, then it's not broken actually. So you just have not made the persistence context yet. So today we are diving deep into this JPA first level cache, which is mandatory and built-in feature of Hibernate that can massively speed up your application, and how it is going to speed up your application, how it will increase the performance of your application, that I will actually discuss. So if you understand how it works, we are going to look at the code. We will trace the SQL logs. You can see those logs actually here. I will not able to show you. If we will run your application from your console logs, you can see those SQL logs, and you can break down exactly what happens to your data during a single HTTP request. So that flow I will show. Plus, stay tuned until the end because I am going to give you the exact answers of the top six JPA related interview questions from this persistence context, which you may face during your interview. Okay, so let's get the golden rule out of the way. The first level cache is the persistence context. So here it is enabled by default. Okay, so you cannot turn it off. So that is one important question that I will discuss in the last as well. So your first level cache is not configurable. This is by default. So every time Spring creates its entity manager and it creates a brand new empty cache. So if an entity a user record is already sitting inside the persistence context, then JPA will completely ignore the database and serve the data straight from its memory, and that memory is your cache memory actually. Okay, so let's prove it with code. So just look simply simple scenario using the entity manager itself. So we open a transaction and we call the find. So here you can see we have created one entity manager object, and then we are getting the transaction. So we have started that one. And then here at first we are going to find from your memory. So memory means I am going to tell you the storage of the memory. Like it can be your database or it can be your cache. So at the very first time when you will call the find for the user ID 1, so Hibernate will go to the database and runs a select query and puts that user into the first level cache. So that is your DB call actually. It will be DB hit. And next time when you will do the same thing again, so then when you will call this find method for user ID 1 again, then if you will check the console logs, then you can see there is only one SQL statement, no second one. So the second find was served instantly from the memory. So that will not hit the DB, and that will come from your cache memory. Okay. So we served instantly from this cache memory. So if you will see the code properly, you will get it understandable. You can get that transaction and it will be committed. And finally, like uh, cache is destroyed here. So em dot close. Okay. So as through the first find method, it comes into your cache memory after the DB call. So in the second call, no DB call will be happened. So no SQL files will be there. So it will be saved from your first level cache. Okay. So why next I am going to tell you why is this so powerful? So let's take a real world banking system like SBI. So imagine a single HTTP request comes into the processor loan. Okay. Now your KYC service fetches the customer. So that data will come from your database. So to your SQL query, database heat will be happen. And after that, the same data will be fetched by your loan service and by the risk service as well. So as these two services again will try to fetch the same data of the same customer, so the data will be fetched from the cache memory itself. So no more DB heat will be there because Spring's dispatcher servlet injects the same entity manager instance per HTTP request across your repositories and services. So you just saved your database from three heavy queries, and that's why like massive performance gain you will get. Okay. Now, in the second, I will tell you about the entity states and bypassing the cache. So the entity states I have discussed already in my last video in the like Spring Boot JPA architecture. So part two video. So there I have discussed like how many states are there. So first one is the new one, then the managed one, next is the detached one, and next one is the removed. Sorry for my bad handwriting. Okay. So, like new means it's just created, okay, with the new keyword, not in cache. So at the very first time, the DB heat will be there. And next, whenever the data got saved, so it saved or fetched, so it is currently in your uh, persistence context, persistence context. Okay, so now it is in your managed state. So whenever at that stage, when the data will be fetched, it will be from your cache. So that cache is only nothing but this persistence context. Okay, and next it will be detached. So that entity manager was closed and or we manually kicked it out. And next, through the removed, we are just marking for deletion. So sometimes you want to bypass the cache. So let's say you did a massive bulk update and you need fresh data from the database. So you can manually like you can manipulate the cache like this. So here you can see in our user service we have the annotation as the persistence context, and we have this entity manager object, and in the manage cache method we are manipulating. So first of all, we are calling the clear method. So through the clear method, all the entities from the first level cache will be removed. Okay. Now through the detach you can pass this user entity. Okay, so through that you are specifically removing the specific entity from that cache. So we are going to specifically remove the user entity. And last, em dot refresh, so we are forcing the JPA to ignore the cache. So we are telling the JPA just hit the DB and update the object. Okay, so in this way, so we will do the bypassing the cache. Okay, with the help of entity states, right? So the biggest mistake the junior developers make in testing an endpoint, like seeing a database query, then hitting the exact same endpoint again and seeing another query and yelling like the cache is broken, but it is not. So remember, like whenever just new HTTP request, like I have told, like suppose two methods are calling in the same HTTP request call, then for the first call, it is taking the data from the DB and next from the cache. But what the junior developer is doing, he is doing the two new HTTP requests, right? So at the first time, also he is seeing like he or she is seeing the SQL query in the logs, and in the second time as well, he or she is seeing the SQL query. So at that point, as the two new HTTP requests, so new entity managers will be there. And as the new entity manager, so brand new empty cache is there, right? So if you want the data to survive across different HTTP requests, you need to configure a second level of cache through your Redis or Valkey or something like that, any other tool that can be configurable. So the second level of caching is configurable, not the first one. First level of caching is your by default one, right? So now I'm going to tell you, I'm going to discuss actually the frequently asked questions from this topic, the persistence context, the first level of caching. So like, is the first level cache shared? No, a big no, right? You all know that we cannot configure the first level of cache. So that is actually by default. So first level cache is default cache mechanism in JPA where entities are stored in the persistence context associated with the entity manager. So can we disable it? So that is also no. We cannot disable it. Now, does save put an object in the cache? So actually, after save entity becomes managed state, this managed state. And whenever this is the managed state, it will come under the cache. So persistence context. So it stays in the cache actually. Okay. So does it store in cache? So after save entity becomes managed and stays in the cache. Now is first level cache configurable? No. So we cannot configure it. It is mandatory and cannot be disabled. When does DB get hit again? So when new entity manager is created, like when new HTTP request, so here flow also I have created. When new HTTP request, the new entity manager created, then persistence context happened. Okay. And multiple find, then one DB hit will be there. So like new entity manager is created, and then entity is actually detached, and cache is cleared, and transaction ends, right? So here I'm going to tell you the good flow. Actually, HTTP request came, entity manager created, persistent context per entity manager. So that's why that persistence context is not shared as well. Now multiple find call if you will do, then one DB it will be there, and the rest for the rest find call actually those will be the cache call. So now the request ends and cache will be destroyed. Okay. So I hope this topic is clear to you. In the next lecture, I will maybe discuss with the second level of caching. Till then, stay tuned and do like, share, and subscribe. So I hope this video will be beneficial for your next interview. Thank you, everyone.